So question number 8, 1.1, what page was it? Page 9? Okay. Yeah, thank you. So we have the picture of the Skylon Tower in Niagara Falls. So the picture says that we have this. And we know that the tower is 160 meters. And we know that when they measured the angle of elevation first, it was 65 degrees. But then he walked 20 meters. And then we want to know what is the new angle of elevation. That's the ultimate goal. That's what we want to look for. Okay? So the angle of elevation after he walked that 20 meters. So in order to find that, I need to know, so if I look at the big triangle, right, because that's the big triangle, yeah? If I look at that big triangle, I only have one side. I only have the 160 meter, right? Nothing else. I don't have the hypotenuse, and I don't have the whole base. But I have the small triangle to give me more information. If I look at the small triangle, the smaller triangle, how much information do I have in the smaller triangle? 2 information, which is an angle and a side, right? And that's enough to find either another angle or another side, right? Now, which one of the sides or the angles is important for me? Is going to help me with the bigger triangle that's highlighted in yellow? Yes. Angles, so the top one, I can do that, but that's another extra step that we're taking, right? Sorry, that's an A here. So I can, yes, by doing 180 minus 65 minus 90, but that's another step that we're taking. I don't have to do that step. What else do I need to find? Side BD, right? If I find side BD, right, and I add it to 20, then it gives me side AD, which is part of my yellow triangle, right? Which is part of my big triangle. Make sense? So I can use, so I'm looking for, this. This is my angle of interest, which is 65 degrees, right? What would be side BD with respect to 65 degrees? Opposite, adjacent, or hypotenuse? So 65 degrees, BD is adjacent.
160 kilometers opposite.
That's the opposite. And then this is the hypotenuse. I don't need it, right? There's not any much information. So I know the opposite, and I'm looking for the adjacent. So out of SOHCAHTOA, which one will I use? TOA. So tan 65 is equal to opposite over adjacent. So my opposite is 160 over adjacent, which I don't know what it is. Okay? Now all what I have to do is, switch the location. So it's adjacent equal to 160 over tan 65. So what's the answer for that? Would it be the same for you? Did you use that? But it's going to give you the same answer, right? Because, so it's going to be 74.6. So that's going to be side BD. Okay? So now I know side BD. I can add 20 to it to find side AD because I know that there is that 20 meter that he walked away. So side AD is 74.6 plus the 20, which is 94.6 meters. So I'm going to draw the yellow triangle on the side, or on the bottom right here. So this is my yellow triangle. I know that this is 160, and I know that this is 94.6, right? And I'm looking for that angle right here, which is angle A. So what do I name? What am I naming here? What would CD be with respect to angle A? Opposite. What would AD be with respect to angle A? And then this is the hypotenuse. I don't need it, right? So I know the opposite and the adjacent, so I'm going to use tan again. So that's going to be tan angle A equals to 160 over 94.6. Because I'm looking for the angle, what do? The inverse, that's right. So tan inverse of 160 over 94.6. And what would be your answer? 59 degrees. Okay, so this is like a two-step question where it's not solved in one step. You have to look at the two different triangles, and then you're going to have to be able to manipulate your work in order for you to have to find the answer. Are we okay with this? Excellent. So today, hopefully, we're going to be able to cover two lessons. So we're going to work on the sine law and the cosine law. You should kind of know them from grade 11, but I mean, they might not be fresh in your memory. Can I go back to the lesson? All right. So we're going to start with the sine law. Okay, so the sine law is a law that can be used, so it's a trigonometric law that can be used with oblique triangles, okay? So let's just recall a few things. So an oblique triangle is any triangle that does not have a 90-degree angle, right? So they're either right angle or oblique. Either or. If it's a right angle, that means we use SOHCAHTOA and Pythagorean theorem. If it's an oblique triangle, then we use sine law, and then we're going to learn about the cosine law as well. Angles are across from the corresponding sides. So remember when naming the angle and the sides, right? Angle A has an opposite side A, and vice versa. All right, now, in order for you to be able to use the sine law, you need to know two angles and any side. Okay? So let's say if I have an oblique triangle here, okay, and I know angle A, and I know angle B, and I know side C, for example. Okay? I can use sine law. As long as I have two angles and any side, I can use the sine law. in this case, in this specific case, in order for me to be able to use the sine law, I need to solve for angle C first. And then I can find I know side C, and then I can find the other sides that I need. Okay? So, and this is where it says use the sum of the angles to find the third angle. So the first thing you want to do, you want to find the third angle in this case. Okay? You have to do 180 minus the 2 angles.
We can add them first and make it a minus.
Yeah, that's right. Okay? Now, in this case, you are looking for another side. So let's say if I'm looking for side A, for example. Okay? Or if I'm looking for side B. So either side A or side B that I'm looking for. The formula that I'm going to use is the following. So it's A over sine A equals B over sine B equals to C over sine C. So you see in this case I have 3 ratios that I'm looking at. But when I'm actually solving the question or the problem, I'm only using 2 of these ratios. Okay? So in this case, if I'm looking for side A, I know angle C and its side, and side C. I know angle A, I'm looking for side A, then I will use A over sine A and C over sine C. Because I know these two, I know the C's, and I know angle A, I'm looking for side A. Do you guys understand that part? So, let's say we have this. That's 30 degrees here. Bless you. Let's say I have this, okay? So you see that I know angle C and I know side C, right? So I can plug in 5 for side C and I plug in 45 for angle C. Do you guys agree with that? All right. So that means this ratio here, I can find the answer for it. It's going to be a number. Now for this side, I'm going to use A because I am looking for side A. So I don't know what side A is, but I know what angle A is. So that means I plug in for 30 degrees here, and then I can use these two to solve for my side A. We'll do examples, okay? But the important part is you use only 2 of the ratios. So depending on what is given to you, you only use 2 of the ratios, either like A and B, or you can use B and C, or you can use A and C like we did in this example. I'll show you how you solve it, okay? Now, this is a case where I have 2 angles and 1 side. The other case is if I have 2 sides and it has to be the opposite angle to one of these sides. I have to know the opposite angle, otherwise it won't work. Okay? So if you know 2 sides and 1 corresponding or opposite angle. So if you know, let's say I have ABC, let's say I know angle A and side A, and I know side C, okay? I know 2 sides and an opposite angle. Then I can use sine law. If you don't know the opposite angle to one of the sides that are known, you can't use sine law. Okay? Because in this case, I can have one of my ratios, like I can solve for it. I know what it is as numbers. Okay? In this case, I can look for angle C. That's the only one that I can look for because I can use the ratio A and C. Okay? We will talk about this again. We will look at an example. It will make more sense when we look at examples. But in this case, because I'm looking for the angle, my formula changes a little bit, and then it flips. So it becomes sine A over A equals to sine B over B equals to sine C over C. Okay? Because I'm looking for an angle in this case. Again, we are using, that's a B. We are using 2 of the ratios at a time, okay? Not 1, not 3, 2. Let's look at an example so it makes sense to us. So I have triangle EFD, or DEF, whatever. And then they're asking me to look for side D. Okay? In this situation, what do I have?
We have 2 angles
And one side, right? So that's the first that we looked at, right? So it's this one, 2 angles on the side. Now, I have an angle on its opposite side, right?
Yep.
And I have this angle, 40 degrees, and I'm looking for this side. So technically, I don't have to solve for angle F because I don't need it. Okay? But if the question was asking me to solve for side F, then I have to find angle F. Okay? But in this case, I don't need to do that because I already know the angle that I'm interested in. So in this case, we're going to use the ratios E and D. Okay? So let's name that. So since I'm looking for a side, that means the side is going to be on the top. Okay? So it's going to be D over sine D. Okay? I'm looking for a side, so my side has to be on the top. And that's going to equal to E over sine E. You see how this is working now? So I'm using 2 ratios. I'm using the side divided by the sine of its opposite angle. And then I'm equaling to the side and the sine of the opposite angle of the other ratio. Why did I not use F? I don't have any information about F. And I'm not interested in it even. Okay? So you must, when you do this, you must know 3 things. Right? And I do. I know angle D, I know side E, and I know angle E. So I know 3 things. I'm looking for the 4th one. Are we okay with this? Now let's put in the numbers. So I don't know what D is, so I'm gonna keep it there. Sine angle D is 40 degrees equal to 38 over sine 95. Any question about this part? Plugging in. We're good? Now, to solve for D, all what I have to do is, I call it half cross multiply. So you're only going to cross multiply one part, okay? Because basically you want to leave D here and you want to leave it by itself because you're looking for it, okay? So all what you're doing technically is multiplying 38 by sine 40, and then you're dividing by sine 95. Okay? So if I do that, I would get 24.5 centimeters. Are we okay with this? What are you doing? You're not putting sine 95 at the bottom. It has to be sine. Just delete it and redo it. Why is it doing that? Maybe you have to put a multiplication between the two. I don't know. Try ending the brackets. I don't know why. Like it works if you don't put that fraction, if you put actually division. I don't know why though. Okay. Are we okay with this? Now, let's look at the second example. The second example is asking us to solve for angle C. Okay? So in this case, I have two sides and an opposite angle. Eyes on the board, please, because this is important here. If you don't have the opposite angle, you won't be able to solve that triangle using the sine law. Okay? So in this case, I have an angle on its opposite side. I have another side, and I'm looking for angle C. So what ratios I'm going to use here? We're looking for an angle. So I have to start with the sine on the top. That's right. So that's sine angle C because I'm looking for that over C. Yeah. Yeah. Mm-hmm. Over side A. Okay? I'm using A and C because I know A, I know part of C, and I'm looking for the other part of it. Is it clear now what I was trying to tell you guys earlier? Okay. Now, I'm using this formula instead of the previous formula, like the one with the side on top, because I'm looking for an angle. So it's easier for me to solve. Okay? There's that option. So let's plug in the information. I don't know what angle C is, so I'm going to leave it as sine C over side C is 12 equal to sine 59 over 19. Are we good with that? Same idea here. I just have to half cross multiply. So that's sine C equal to 12 sine 59 over 19. And that should be 0.54136. So you see that when I get this answer, I did not stop at one decimal place or at two decimal places. I went like 4 or 5 decimal places because you want these decimal places for an accurate answer. This is not my angle, right?
No.
How do I find my angle?
Square root. No.
Sine inverse, because I have sine C, right? So angle C, you do just the sine inverse. So you do second sine inverse on your calculator, right? You're going to try to use as many decimal places as you can, and then you should be around 33 degrees. It's 32.77, right? Yeah. So you will get 33 degrees. Are we okay with this? All right, so sine law can be used when I don't have 90-degree angle.
Got 32.
2.77, yeah, so that's round up to 33, right? Because it's an angle. So,
You only have to do the inverse sine for the angles.
yes. So anytime you're looking for an angle, you're doing the inverse.